Of the four operations, that is insertion, deletion, search, and updation, the most important operation is actually the search operation. So search is a very important operation which ultimately decides the performance of any database management system. Can anyone quickly say why this search is important among all the four operations: insertion, deletion, modification, and search? Anyone, please?
Sir, the highest number of times we require searching through the existing data, and there are multiple rows. So in order to get the right row in the required time, we require indexing.
Okay. Now I am asking about the importance of the search operation. Among the four fundamental operators, that is
Sir,
data insertion.
sir, I believe that for insertion also we need to find kind of do a search operation to know the search position, and to deletion also we need to first find the record. So searching is implicit again there. Even for modification, first we have to search for the record and then we will be modifying the record. So I think search is kind of encompassing all the three other operations.
Okay, that is correct. Actually, search is actually coming as a pre-operation before insertion, deletion, and updation. So if you modify or if you make search efficient, all the four operations will become efficient. So that is the reason why searching is very important. So I mean, search is very important in the context of DBMS, and indexing is actually a technique which will help the search operation efficient or faster. All right. So let us see about the importance of different types of indexing that is followed in database management systems. We know that there are basically three main techniques for indexing. One is actually the conventional dense indexing with a page table where we have dense indexing, sparse indexing, etc. And another method is by way of B trees and B plus trees, where we can perform better or these two indexing mechanisms, B tree indexing and B plus tree indexing, can perform better when records are constantly added and deleted. And a third technique is actually the familiar hashing technique. First, let us see the conventional indexing methods. So a database index is actually a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and storage space to maintain the index data structure. All right. So this is a definition taken from Wikipedia. So a database index is an additional data structure or additional storage that is maintained along with a relational database, which can improve the speed of data retrieval operations on a database table at the cost of additional writes as well as additional storage space, and it is used to maintain the which are used to maintain the index structure. All right. So you require additional write operations and you require additional storage space to maintain the index data structure. So it is actually an additional data structure which is maintained along with every table to make basically the search operations faster. Okay. So this there are two types of indexing. One is actually called the sparse indexing, and the other one is known as the dense indexing. I'm sure you are familiar with these two types of indexing mechanism. In the case of sparse indexing, there is one entry for every data block. Corresponding to every data block, you have an entry in the index table or in the index file. So this you will have only one entry corresponding to an entire data block. So this entry will identify the first record, or it will point to the first record in the data block. And this required the data blocks to be sorted in some order, some chronological order. Whereas in the case of dense indexing, there will be one entry corresponding to each database record. Okay, so the data do not have to be sorted. So in the case of dense indexing, suppose you have 10,000, or if you have 1 lakh records, so there will be another file which is actually the index file where you have 1 lakh entries. So one entry corresponding to every database record. So that mechanism is actually called the dense indexing. And in sparse indexing, there will be one entry corresponding to a group of records, or it is corresponding to an entire data. So there the requirement is that the data should be sorted. All right. Whereas in the case of dense indexing, the data need not be sorted. It is not compulsory that the data are sorted. So the advantages of when you compare these two in the sparse indexing, it requires only less space because you have an entry corresponding to a data block. Maybe the data block may contain 1,000 database records or maybe 5,000 records. For 5,000 records, you have only one entry in the table. And sparse indexing can keep more of it in main memory. All right. So the entire sparse indexing table can be kept in the main memory, and this will allow faster access. If you have the whole index table in the main memory, fitting into the main memory, we can search the faster memory, which is actually the RAM. Whereas in the dense indexing, we can tell if a given record exists without accessing the file. So that is actually the advantage, because every entry in the index file is directly pointing to the record. So without reading the whole file, you will be able to say whether the record is present or not. And this does not require the data to be sorted. The data can be in any form. So now let us see what is meant by this indexing based on primary keys. All right. So we know that when we are talking about database fields, you can have at least one attribute which is designated as the key attribute. There can be multiple key attributes. In that case, you will say one is primary key and other is secondary key, like that. So you have different terms: primary key, secondary key, super key, like that. These are all referring to various fields in the record. So can anyone distinguish between primary key and secondary key of a table? Abhinijit?
Yes, sir.
How do you distinguish between primary key and secondary key?
Primary key is to use to identify a tuple uniquely.
Secondary key?
Sir, I don't exactly remember.
Okay. Divyanshu Singh?
Yes, sir.
Yeah. How secondary key differs from primary?
The primary key is a unique key, but secondary key I didn't remember, sir. Actually, primary key is unique and not null, but secondary key I didn't remember, sir.
Okay, you are not remembering. Devendra?
Yeah.
Devendra? Karthik,
So, sir,
yeah. How
uh,
secondary key is different
primary,
from primary?
primary key is minimalistic key at group of attribute which can uniquely identify all the tuples. Uh, like secondary key is the key which is not primary among the candidate keys.
Okay,
So if
so you are
among
talking
many
about
candidate
yeah,
key, one is primary key and the other key selected as secondary key.
okay. So you have a, I mean, normally, or there can be a situation where there are multiple attributes or multiple fields which are capable of acting as the keys, key attribute. So you call all of them as candidate keys because they are candidates for acting as keys. So out of the candidate keys, you may select one particular key as the primary key. So the selected candidate key is actually called the primary. So other keys are also equally capable of uniquely identifying a database record, but due to some reason, some implementation efficiency or easiness, you may choose one field as a primary field or primary key. Okay, so we can say that the selected candidate key is actually called the primary. When the primary key is not available, or the second candidate is actually the secondary key. All right. So how do you select a primary key? Any guidelines for that? For example, you have roll number which can uniquely identify a student, or you have your Aadhaar number which can also uniquely identify a student. In a university or at NIT Calicut, when you are implementing a software for NITC, student management system or academics management system, which you will select as the primary key. Will you select the roll number as your primary key, or will you select Aadhaar number as the primary key? Megha,
Yes, sir. We will select roll number as a primary key.
Koi,
Hello.
yeah, Koi, what is the reason, Megha? How do
Because
you
roll number for each person is unique. It will be unique for everyone.
yeah, Aadhaar number will also be unique for every student.
Yeah, like mail address. It can be. You can use mail address also.
Yeah,
Email address.
yeah. So you are saying email ID is there, Aadhaar number is there, roll number is there,
Yeah.
but you
Yeah.
are selecting roll number as the primary key.
Yeah.
How do you justify that?
Because it will be very convenient to use because we are distinguished by roll number only.
No, you can also call by your email ID. That will be
Yeah.
more easy for people to remember.
Roll number will be it will be very short and it will be integer type. That's why.
But our roll number is not integer type. I think you have said,
Yeah.
what is your roll number?
Yeah, M2210252CS.
Okay.
It will be alphanumeric type. It is alphanumeric type.
So what is that M representing?
It is alphabet.
Yeah, what does it carry any meaning in NIT?
Yeah, MTech.
MTech.
M
What
stands
are
for MTech.
okay? What are the next two digits?
Yeah, 21021. It will be the year. It is the
Year
year
of
of the
admission. Okay.
yeah.
Then
And
M21.
0252 is our roll number.
Okay.
And CS stands for computer science.
Computer science. So by looking at your roll number, we can say that you are an MTech student, you are in the CS
Yeah.
department and you got admission in 2021. All right. So
Yeah.
all these things, these are all additional encoded information. And all students
Yes,
have,
yes.
these require only, how many digits are there in the roll number in this case? M21
6,
0252.
7, 8, 9. 9,
9. Okay. So the Aadhaar number is having 12 digits. All right.
12 digits.
Yeah.
Yeah.
And your email ID may have varying size. Someone will have 6 characters. Someone will have 12 characters. Long email ID, small email ID. There is no fixed number. So in this
Yes, sir.
context, in the context of a university, from your roll number, a lot of things can be deduced for a academic system or for a university. Whereas Aadhaar number also carries a lot of information. I think from the Aadhaar number you can find out your PAN number, your bank account number, many things. But actually the university or NIT Calicut is not bothered about any of those things. But they are, I mean, if you can identify from the first, I mean, if you can answer a query regarding, give the names of all MTech CSE students who were admitted during 2021. So the query can do a parsing on your roll number. So it will look for the match M21 star CS at the end. All right. So any roll number starting with M21 and some asterisk stands for a wild character, and finally ending with CS, it will list. So searching is going to be directly easy with this particular key. So what I'm saying is, due to this is actually the convenience that some of you were talking about. So in the context of a university system, roll number is actually going to be a very practical or useful or a convenient key. Maybe when you are talking about a bank or when you are talking about the income tax department or your revenue department of the state, so they may prefer Aadhaar number as the key. So depending upon the application, you will do a selection on the key. So the selected candidate key is actually called the primary. Then what is actually other keys are maybe Aadhaar number can be the secondary key, or as Megha was telling, maybe the email ID can also be a secondary email. I mean secondary key, but the email ID doesn't have any fixed length. You can have an Yahoo ID, you may have a Hotmail ID, you may have Gmail ID, you will have NITC ID. So the length can vary from, or you will have an IEEE.org ID. So the email IDs can have different domains, different names, and there is no uniformity as such. All right. So there is another term related to this, which is actually called the super key. So can Neetu say about the super key? What is the super key?
Sir, it's a set of keys where one will be a primary key and few more keys are added to make it a super key. A super key can also be used to uniquely identify a row.
Okay. Super key is actually the super set of all the candidate keys. All right. So here you were talking about 3 keys at present, that is Aadhaar number, roll number, and email ID, or probably the mobile number of a student. Okay, mobile number. Then normally everyone, let us assume that everyone will have a unique mobile number. So roll number is a key, mobile number is a key, email ID is a key, your Aadhaar number is a key. So all these things put together, we can call as the super key. So the super set of all the candidate keys is actually called the super key. So in that way, we can say the minimal super key is actually called the key or the primary key. The selected minimal candidate key is actually called the primary key. Okay. So in this case, indexes are based on, when you are talking about indexing are actually based on primary key. Each key value corresponds to a specific record. So each roll number corresponds to a specific student record. So there are two cases to consider. The table is sorted on its primary key. Let us say the student table is sorted on the roll number. So can use, you can use either sparse indexing, or you can, because the student records are sorted according to the primary key, you can use primary key as the sparse index, as a sparse index. Or the table is either non-sorted or sorted on another field, then you must use a dense index. So here the point is that suppose the database records are sorted according to the roll number, or the database records are actually sorted according to the Aadhaar number of the students, but your index table or your primary index, the key that you have chosen is roll number, then will there be any advantage? The database records are stored according to the Aadhaar number, the sorted order, and your index table is sorted according to the roll number. So will this be useful? Piyush Abhishek?
Sir, can you say it once again, sir?
Yeah, your student records are sorted according to the Aadhaar number,
Okay, sir.
but your primary index table is sorted according to the roll number. Will it be useful?
Sir, if it will be sorted according to my roll number, then it will be useful, sir.
Yeah. So here the point is that when you are choosing the index table or the field for indexing, it should be used for, the database record should also be sorted in that particular, using that particular field. So you are sorting the index table based on a field, and you are sorting the database record based on another field, then there may be an issue, or there may not be any advantage during searching for the data. All right. Okay. So sparse indexing occupy only less space, and it can, okay, this we have seen already. All right. Okay. Here there is an example of sparse indexing. So what you see here is actually the sparse index table. So this is a small table where there are only 3 entries. So this is actually the index field, and this is actually the pointer. Okay. So here, as it is quite clear, so there is one entry, the entry starting from entry pointed by Alan is pointing to 4 records, and the entry pointed by Dana is pointing to another 4 records. So this is actually called the block of data, database block, a block of or a group of records. So when you search for Brenda, what you do is you search here, maybe you can do a binary search here and find that B is coming between A and D. So you will follow this pointer, and here you search sequentially and say that Brenda record corresponding to Brenda is available. All right. So here there are actually 8 records shown here, but corresponding to these 8 records in the database, we have only 3 entries in the table, index table. So that is why it is called sparse indexing. Sparse indexing means one entry in the index table corresponds to a group of records or a database block, data block. So here you can see the dense indexing. In this example, you can see that there are 8 records. Ahmad, Frank, like that, you have 8 different records. And here also you have many, you have more number of entries in the index table also. So corresponding to every data record in the data block, you have an entry in the index table, a dense index table. So you have Ahmad pointer pointing only to the record corresponding to Amrita, Ahmad. Amrita's, this pointer will point to the record corresponding to Amrita. Viranda, that will point to this one. Then Carlos, it will point to that record. So if there are 10,000 records here, you will have another table, 10 index table with 10,000 entries. But as you have seen, this need not be sorted. This index table can be in any order because if it is sorted, it will be easy for you to conduct a binary search. But once you get the record, you can, the data records are not sorted because you can just see Ahmad and Amrita is coming here. So the data records need not be in the ascending order or alphabetical order. It can be, because you have only the index table need to be sorted. So here you conduct a binary search and get the corresponding pointer, and then you are accessing the data directly. All right. So you can do indexing based on other fields in the database record also. Each key value may correspond to more than one record. So that is actually called clustering index. Okay. Clustering index, can anyone say about database table clustering? Rahul, Maharana. What do you mean by database clustering? Rahul? No response from Rahul. Piyush Abhishek?
Yes, sir.
Yeah. What is this database clustering?
More than one data is collected and kept in the database, sir, like one type of data. Different types of clusters having different types of data in there, sir.
Okay. So actually clustering is totally a different, I'm not talking about clustering index, but clustering is a different concept. For example, who is your faculty advisor, Piyush?
Priya, ma'am.
Okay. So what is happening is, let us say that when someone is searching about a faculty, okay, so the next query is about all the students who are under the FA ship or faculty advisorship of that particular faculty. So if there is a pattern, you are searching for Dr. Gopa Kumar, and next query will be about all the students who are coming under his FA ship. So in that case, what we can do probably in the database is to store a faculty record, and in the next locations or in the locations near to that, you store all the student records which are coming under the FA ship of Dr. Gopakumar. So when you read the record corresponding to Gopakumar, actually in the disk read, you will also be getting the details of all the students into the main memory. So in a single read, you get the faculty record plus all the associated student records. So the next few queries are based on the students who are being advised by Dr. Gopakumar, then all those queries can be answered based on the data which is already there in the main memory. All right. So that is actually the advantage of clustering. When you read the record of Priya Chandran, or when you read the record of Priya, you also get all the students who are coming under the FAC of Priya. So you need not read those student records again and again. So in a single read, you will be able to get the faculty plus all the students associated with that faculty, so that many queries coming after that can be answered directly with a single read. Okay. So that is actually about clustering. So when you are considering this, you should make sure that the tables are sorted on the field, and it can use a sparse index. Table is either not sorted or on another field, and you should use, in that case, you should use a dense indexing mechanism. See, normally, as we have seen earlier, we will choose a convenient attribute for acting as the primary. So, roll number, in our case, we have assumed that, or we have found that roll number is going to be a convenient choice, or it normally as a primary. But Rahul Soni, do you know the roll number of Rahul Moharana? Rahul Soni? Hello? Hello?
You're audible, sir.
Yeah. Rahul Soni, do you know the roll number of Rahul Moharana? Do you know his roll number? Why don't you unmute and say, Rahul?
Sir, actually, his mic is not working. He's commenting.
All right. Okay. So he does not know the roll number of Rahul Moharana. Or Ria, do you know the roll number of Rahul Soni?
No, sir.
You don't. So the thing is that even though we are choosing roll number as a primary key, except that person, no one will be knowing the roll number of the other person. Or in short, I can say that while searching, nobody will be searching based on the roll number. Maybe the FA or the faculty advisor may be using. Other than that, when students are searching, or even when faculty members are searching, they will be searching with a name, or they will be searching with email ID. So nobody will search with the roll number. So even though roll number is practically good for storing the database or for arranging the records, it is not a popular field. You may be knowing the name of the student, you may be knowing his email ID, you may be knowing his mobile number, you may know his CGPA, SGPA, you may know from where he is coming, you may know his room number in the hostel, but you may not be knowing the roll number. But you are using roll number as the index key. So without knowing the roll number, you will not be searching the database. So that is actually a problem with primary indexing. So sometimes you may have to create additional index tables which are based on popular fields for the usage. So people will be preferring to search a person with his name, or people may search with their WhatsApp number. So they may not search with the roll number. So always the primary key or the chosen candidate key may not be the best choice for searching. All right. So here you can just see a sparse clustering example. Okay. So you have the record of past posting pointing to this data block, then Dallas pointing to another block. All right. So dense clustering. Here there is again another example. All right. So you have one second. Okay.
He visited here.
Okay, so this is another example. So we can see that multi-level indexing. So you have first level indexing, which will take you to another table. From there, you will point into the actual data record. That is actually multi-level indexing. So you have a primary indexing followed by a secondary index table. Then you will get the pointers to the actual record. So in this way, you can reduce the size of the main index table. Okay. So from the first index table, you will move to another index table. From there, you will be moving to the actual database. So this can be in 2 or 3 levels. So if you make one more indirection, so the size of the main table can be reduced. So if the main index table is very large, the problem that one may face is that it will not get fit into the main memory, or it will not be fitting into the RAM. So you can have multiple levels of indexing. Okay. So when you are having we can solve any problem by introducing an extra level of indirection, except of course for the problem of too many indirections. Yeah, you have to first search in the first table, get the pointer to the second table, then search in the secondary table, get the pointer to the third table. Like that, you have to do it in many phases. In that way, you may be spending more time, but you will be saving some memory. Okay, indexing the index. So when index is very large, it makes sense to index the index. So 2 level or 3 level of indexing. So index at top level is called master index, and normally it is going to be a sparse index. That means one entry corresponding to multiple records. So this is an example, outer index pointing to the inner index, and from the inner index you get the database block. So here you can just see that this is pointing to this block. From there you get the pointer to the data. So you go for multi-level indexing so that you can reduce the size of the index tables. So now we will go for B trees and B plus trees. So balanced trees and another improved version of balanced trees we call as B plus trees. So this is also an indexing mechanism. So B trees and B plus trees are well-known data structures, and they are well known for their property of called the balance property. All right. So the balance property of B trees are used along with the indexing concept. That is what is actually called the B tree indexing. So tree is a versatile data structure, which is a dynamic data structure, and B trees are having an additional property of balancing. So these two are combined with the indexing technique so that what you get is actually called the B tree indexing or B plus tree indexing. So we will look into the benefits of combining the what is happening is the index table. So what we have seen earlier, this table is actually replaced by a B tree or a B plus tree. So tables are actually static data structures with fixed width, etc. Whereas B trees are actually, or trees are actually dynamic data structures which can grow or shrink as per requirement. So the dynamism or the dynamic nature of the tree structure plus the balance property will help you in maintaining the index. So that is actually the advantage of B tree and B plus trees. All right. So we will see more about B trees and B plus trees in the next class. So we will continue in the next class. Any Q questions?